Well, hello everyone. I'm here with Dr. Holly Henry. She is professor in the Department of English at Cal State San Bernardino, and she has just come for a conference on space science and spirituality that I've been involved in. And she's got a lot of background, even as an English professor, she's got a lot of background looking at various issues in the kind of history and technology of space travel. So I wanted her to talk a little bit about some of this and how it might relate to ultimately the digital humanities, but more importantly, the notions of visualization and simulation and things of that nature. And this happens to be a very exciting weekend because the book that she's been working on for, 4 years now, comes out this weekend. Why don't you tell us about it?
This is the book, Dreams of Other Worlds, The Amazing Story of Unmanned Space Exploration. And the book is... are we looking at each other?
Yeah, we can.
Okay.
That's fine.
All right. The book is an account of 11 space science missions that were iconic missions that we've done of unmanned space exploration, flying first to the inner planets with Viking and then Voyager, visiting each of the major planets, Cassini, which is now still at Saturn, Hubble Space Telescope, Spitzer is a space telescope that sees in infrared, Chandra in X-ray, and it's given us over the past 40 years a very different sense of who we are in terms of who we are as humans and what our relationship is to not only the planet Earth but also to space itself.
Right. So you wrote this with a colleague?
That's right, an astronomer, Chris Impey at the University of Arizona.
Okay. So this book strikes me as a kind of combination of kind of a scientific account and also a social account, or how these things actually affected our understanding of space, our understanding of the universe. Is that
that's
right?
Absolutely. The one portion of each chapter treats both the scientific achievements of these missions, but also comments on how these missions have had an impact on popular culture, on how the science has had an impact on popular culture, how we understand where the human body comes from, where everything comes from is everything that is made out of recycled stardust. So it was an opportunity for us to do both serious science and to see really the history of the science, and also what it has meant to humankind and what it will mean for our human future.
Right. Well, that's really interesting because sometimes we think about this, just as a kind of scientific enterprise, as a technical problem, I suppose. And so what you seem to be saying is that there's a very human element to this. I mean, what's interesting to me is that your background is actually in English and Virginia Woolf and people like this, right? So I think some people might think, what an interesting and strange trajectory into this. But how did you get interested in this? And as a humanities scholar, why do you find this interesting as something other than just a scientific problem?
Those are really good questions. I did my degree at Penn State University, and when I was there as a grad student, our professors at that time were working in something called the Cultural Studies of Science. Now it is spoken of as Science Studies, Cultural Studies of Science, bringing together the arts, the humanities, and the sciences to see what these disciplines have to say to each other. Because our lives are lived in an interdisciplinary space of every day we navigate information not only about human concerns, but also about biology, about astronomy, will an asteroid hit the Earth, about medicine. All of it is intertwined in our own lives naturally, so why not in the disciplines themselves? So at that time I was in the English department at Penn State and choosing my major, and I thought that I wanted to work on Virginia Woolf, and there were many images of stars and planets and just all these astronomical references, and I thought, my God, there's a thesis to be written on what Woolf's interest was in astronomy. And so I was able to do that with my master's thesis, and I've always been interested in space from a young person, but women weren't recruited into the space program when I was growing up. Women didn't fly jets in the military. There was no access to space for me, sort of in any profession. And even women in astronomy departments and in physics departments was still very rare.
Right.
So now it's much more populated with,
Right.
our women students, and that's fantastic.
Right.
But this was a way for me to, I had gotten my degree in English in my undergrad and master's, and this was a way for me to really pursue a passion, which was astronomy, and link it to my work in literature and literary theory.
Wow. So, I mean, I think it's really interesting that this is such a multifaceted thing. And, one of the aspects that I know we're looking at in the digital humanities is modeling, simulation, visualization, things of this nature. And, and I'm wondering, has that been an issue? I mean, obviously we know about, the IMAX films that have been taken in space. Probably a lot of people have seen those. And but what role does that kind of visualization have for the general public? Is it science education mainly, or does it do something more than simply get people excited about solving scientific problems?
I think it's both. You can convey with an image. It's really true that a picture does say a thousand words or something like that. You can convey in a single image the tremendous power of a stellar explosion. Once you understand the scale of the blast waves that you're looking at, or seeing the surface of Mars, it doesn't take rocket science to see that there's water erosion. We can see these features, and it's accessible. The kinds of cameras that we've equipped our Mars rovers with, and our Mars Global Surveyor and other spacecraft that are in orbit around these planets, Cassini. Even just general audiences can make sense of the data in a single image. We can sort of see the kinds of processes that are at work and realize that the whole entire solar system is populated with moons that are really they're truly worlds in their own right. And so yes, it is, the cameras are there for the serious science, but they're also there to generate public interest and to convey very quickly what's happening on these other worlds that we're exploring in space, and why it's relevant to us in our search for understanding the origins of life. And does it have to be in a liquid environment? That's what we assume. And so the cameras are an educational tool, but they also show us something about our human origins, and speak to that question of why are we here? Where did we come from? How did life emerge? These are deep questions, or deeply philosophical.
Right.
And whether you're 85 years old, 65, 50, or 25, we deeply, innately as humans are curious to know these ultimate questions.
Do you like science fiction?
I do. I like science fiction very much. My discipline of the cultural studies of science is I study the real history of science.
Right, yes.
But I also do teach science fiction, and the truth of it is that much of science fiction often sets up questions and scenarios that decades later or 100 years later we're actually grappling with. It was the case that Jules Verne very much researched what would be the possibility of going to the moon. And he set up the title of the book, From the Earth to the Moon. The subtitle is like in so many hours, or so many days and hours. And in fact, it is exactly right. 3 days and some odd hours. And he was exactly right. That's what it takes for if you know this escape velocity from the Earth, the distance to the moon, you know what it takes in terms of sheer time and distance to get there. And he was right. He actually has his astronauts, the men who decide to build this cannon to shoot the missile to the moon. He has them trying, not the astronauts, but the mission planners.
Right.
They're either going to launch from Florida, or they're going to launch from Texas.
Right.
And he knows it sits close to the equator, and so in terms of lifting power to escape Earth's gravity, you're working with the assist that you get from the turn of the Earth at the equator.
Yes.
And he knew that. And in fact, in the follow-up novel, I forget what it's called, Around the Moon is the follow-up novel. He has them land their space capsule in the Pacific Ocean, even as we did with the Apollo missions. And of course, Wernher von Braun and many of the people who really made it possible, Goddard and others, who made it possible for us to build the rockets to go to space, they read these books and they knew them, and they were inspired by the very real science that was that had inspired Verne himself, and that he translated into these images. Even the multi-stage sort of rocket train that Verne has illustrated, taking his characters to the moon. We did a multi-stage rocket, so it's kind of fascinating.
I mean, the reason I brought this up, and that's amazing that Verne, figured all that stuff out or knew it, or
knew someone who could help him,
assist,
and advise him.
But it seems like that's a kind of pretty basic sort of visualization that we have, right? It's our imagination. We are able to think about these things that very few people have ever been to, and so I'm interested in the kind of ways that we've found to aid that imagination. And you were telling me a little bit earlier about some digital tools that NASA has and some others to try and capture some of that.
That's right.
So would you mind showing us a little bit of that?
Sure, I would
Great.
be delighted.
Excellent. All right, so you're going to show us a little bit about some of these visualization sites on the internet right now, especially that from NASA.
That's right. NASA has had an initiative to make more of its data available to the public, so that the public can see the kind of work that they're doing and provide these more immersive programs, and using the data from Kepler and Spitzer and other space telescopes to sort of get us into the space of the solar system. So we're going to go to Eyes on the Solar System, particularly a program called Eyes on the Exoplanets.
Great. So we go to this site and it has us download something, which I've already done. It's right here. And so we'll bring it up and we have, looks like this. And so we hit start on this one and it's just going to fire up here. And we're going to take it full screen and we're going to turn the audio off. So what are we looking at?
Okay, so we are seeing the stars in the near Milky Way around our sun, and we're actually, it says where planets have been discovered. That's what we're looking at. Our sun is at the center, and then it shows us our sun's location in the Milky Way galaxy, of which there are 400 billion stars.
It's mind-boggling, isn't it? I mean, just 400 billion in this galaxy, and then there are billions of galaxies.
Billions and billions of galaxies.
Yes.
That's right. So we're watching these various stars, and the names that you see here are the planets that have been identified that are orbiting these other stars. And you'll see at the bottom here that the planet count is 905 so far identified, and the stars with planets are 697, so that some stars have multiple planets orbiting them, just as even as our sun does.
And 0 Earth-like so far.
And 0 Earth-like so far. So
we're looking.
That's the holy grail of astronomy, really. Currently, there's lots of projects in astronomy to explore, the universe and the Big Bang and so forth. But this is one of the big questions: is if we could find an Earth-like planet, because we might find life other than on Earth itself. Right.
Great. And so these are all generated from things like the Hubble and Kepler and other missions that have had a kind of eye on the distant, but in our own galaxy.
In our own galaxy, right. These are stars within our own galaxy. One particular mission named Hipparcos has mapped the stars out to about 500 light years from Earth, very accurately. And a new mission coming up, Gaia, is going to map something like 1 million stars very accurately in the near galaxy.
And so to get some kind of sense of how much of the galaxy that is, 500 light years out, the galaxy is what, 70,000 light years across?
100,000.
100,000 light years across. Okay,
yeah.
so
very small portion. We're mapping just a very small
kind of the
portion.
neighborhood that we're.
That's right.
Right.
But even in doing that, we're finding exoplanets orbiting other stars, which indicates that there are probably billions, and there are billions and billions of planets in our galaxy.
Great. So show us what this does.
Okay, so this particular program allows us to explore these exoplanets. You'll see here the highlights of news that might be relevant, and we'll just go to this one. Kepler finds possible ocean planet.
Mhm.
We're told that it's a hot Jupiter,
Right.
but it's one of the most promising exoplanets in the habitable zone ever found. And here you have sort of a virtual representation of the
Hmm.
of this solar system. We'll go to Kepler 62e.
And there it is.
There it is, and we can get some information about the planet itself. This is a type of extrasolar planet known as a hot Jupiter, composed almost entirely of gas like Saturn and Jupiter in our own solar system, but with a high surface temperature because it's located very close to its parent star. We can see if it is indeed in the habitable zone of its star.
And it doesn't. Well, it looks like E is just barely in.
Yeah, I think that's right. It looks like E is this orbit right here, and that looks like that is within its habitable zone. And so far as I understand the definition of that, it's whether or not water could exist on the surface of the planet.
So it's not going to look at things like atmosphere quality or something else.
No.
Just water at the moment.
I think right now it's a spatial designation.
Right, got it.
Within this type of star, the age of the star and the size of the star, what would be the habitable zone of planets orbiting that particular star. And then you can compare it with our solar system to see what the size of this system is compared to the size of ours. Let's see.
So it looks like Kepler 2e is maybe around the orbit of Mercury compared to us. Is that right? Or
it would be this one.
that one. That's
oh
right.
yeah,
but
that's the one about the orbit of Mercury. So
right.
we expect that it would be hotter than.
Yes. Right.
Did it give us some details? It said it was a hot Jupiter. It said the size was about the size of Jupiter. Planet radius. Its orbital period is 122 days.
Mm-hmm. So about a third.
And its orbital radius is about half of an astronomical unit, and we're at 1 astronomical unit.
Got it. Yeah. Right. Interesting.
All right. And then a few other features of this program is that you can look at the latest discoveries of planets. We'll go to Alpha Centauri B, since that's the star system closest to our sun.
Okay. Rocky planet this time.
It's a rocky planet. And here we have the planet orbiting. I'm just going to click on it to see what we can learn about it.
And now these are just artist representations, right? I mean, we have no real idea of what they look like.
No, at this point we don't have that kind of detail of visual data. But with the new James Webb telescope, which will be an infrared telescope, we will gain much more information and be able to understand more of the geology of the planet and also characterize its atmospheres.
Right.
So to get a sense if there's oxygen in the atmosphere, water vapor. This planet is thought to have a compact rocky surface like the Earth's. The 4 innermost planets in our solar system are terrestrial in character. And so we're thinking that if we could find life, it might be on a rocky world. But that's not necessarily the case. If we just look into our own solar system, many of the moons of Jupiter and Saturn have frozen ocean surfaces, and we think there could be life under those. So it's not just these habitable planets, but possibly even the moons.
The moons of them.
If it is a hot Jupiter, it might have a moon that is habitable, as we saw in the film Avatar, in which James Cameron depicts Pandora as a moon of this massive, as a moon of this massive planet.
Very interesting.
And other features here. Let's see. So you can search for exoplanets by name or by type.
And do they have, I mean, so far we've just seen the planets basically being numbered.
Right.
Are they being named in the, I mean, asteroids get named for people. And,
that's right. Yes, one of the planets that we found was the first circumbinary planet. That means it orbits 2 stars in its solar system, and it has a stable orbit. And it also means it would have a dual sunset, like we see in the film Star Wars with the planet Tatooine, where who's our character?
Yes, Han Solo and Luke Skywalker.
It's Luke Skywalker is from Tatooine.
From Tatooine,
yeah,
yes,
that's
exactly.
Right. And so he has a dual sunset that he sees setting.
So did they call it Tatooine?
They called it the Tatooine planet.
There we go. Excellent.
I'm sure it has a scientific designation also, like Kepler something.
Right. I'm sure George Lucas is very pleased.
It's actually Kepler 62F or something like that.
I see.
Yeah, we could try to search for that. But and then let's see. So we can see something about these missions that are looking for those planets, and We can learn how long it would take to travel to a particular planet.
Oh yes, I want to know how long it would take to drive there.
To drive to this planet would take 47 million years.
Excellent.
So that is
Excellent.
too long, but we could try it at light speed. And it would only take 4 years to travel to this planet at light speed. Right now, there's an initiative by DARPA and also by other space interest groups to build a starship, to actually take something like science fiction, Star Trek, seriously and build a starship. It's called the 100-Year Starship Project.
Right.
That's the one sponsored by DARPA. They meet annually to bring together not only scientists and space engineers, but philosophers, humanities poets, artists, to bring all of these perspectives into the same room to think together what it would take to build a starship, what we would have to consider in terms of preparing those people for such a mission, as it might be a one-way mission, and all of the tools that they're going to need, the critical thinking tools they're going to need from religion, from philosophy, from other disciplines, the arts, that will be very important in making such a voyage.
Well, there's just been a call for people who would be willing to go to Mars, and how many people signed up for this one-way trip?
I thought it was something like 10,000.
It was an incredible number.
Yeah,
Yes,
thousands of people were willing to make a one-way trip to Mars to risk the frontier experience and possibly even die on. Obviously, not possibly, but would plan to not make a return.
You're not
trip.
coming back. Yeah,
That's right.
That's amazing. Yeah,
That's right.
So, all right, this is a really amazing simulation, and I think what I really am interested in here is, while it's a simulation that's based on scientific data, I think it has some interesting humanities implications as well. I mean, as you already mentioned, the long-term space flight would have to consider, issues of meaning, issues of myth, of narrative, of all sorts of things, and not just where do we get our water from, and how do we keep our muscles working properly.
That's right. Yeah, it's actually a biblical scripture that says something like, without a vision the people perish.
Right.
And this is really what philosophy and the arts, music, these things are deeply vital to us, considered to be actually technologies that emerged for the very survival of humankind. So if it took philosophy, narrative, storytelling, art, music, dance to help humans evolve from the Stone Age into modern, sort of our modern technological age, we're going to need all those tools.
Right.
If we would consider getting in a starship and flying off to another planet.
Right. Well, this is great. Thanks for showing us this. Now let's take a look at some of the other things we have available.
Okay, it also shows you, in this program, or did you?
If there's more in this one, that's great.
It also shows you where these stars are in the night sky.
Oh yeah, right. That's great.
From the surface of the Earth. So if you went to Buenos Aires, you could see the stars in the night sky above the surface, above the horizon of the Earth. And I think this is a real-time data, so that if the Hubble Space Telescope flies over, you would actually see it tracking across the sky.
Well, I mean, I did see something just move right down here, and so it does give me a sense that maybe it is real time, and that they're tracking these things.
Yeah, I think that's true.
Which is amazing. I mean, to think that you could, just kind of, that this is that accurate a kind of representation.
That's right. And we also see planets from our own solar system right there with Neptune.
Right.
So it's trying to give you an immersive experience of getting a sense of place in the solar system and far beyond.
Right. And there it is.
That's Neptune. Yeah.
Yeah. Wow.